We'll take the second part. And as you could hear from the introduction, we are both from Thermo Fisher Scientific. So my first question to the audience is, who knows Thermo Fisher already? A few hands, but not so many. So let's see if we can get some lights on the screen behind me. So we have a company, and we are the world leader in serving science. That means that what we provide are solutions, products, consumables, and services to, in a lot of cases, lab environments, so lab spaces. We are pretty big. Across the world, more than 100,000 people, and we invest a lot of money in research and development. So that's us. Our mission, we enable our customers to make the world healthier, cleaner, and safer. So definitely the topics of the previous speaker also relate much to what we do in our company. I won't go through all the details, but here you have a bit of an overview of the kind of products that we bring to market across the world. The one that is in the middle, and it happens to be in the middle actually with our corporate slide deck, but that's where we happen to be. We are in Electron Microscopy. So that is what we do. We do that here in Eindhoven as one of the locations. Electron microscopy, I think everybody knows microscopy. It magnifies things. And the way how we magnify is really nicely shown by this first little video that we have for you. And what you see to the left is, of course, you are pretty far away from Earth. And to the right side, we have a leaf. And we have a little animation, and it shows you how we actually can zoom into the atomic level with our microscopes. It's a quiet video. We have some more sounds coming. There you go. And we're almost there. 1 nanometer. We go to the angstrom level. Yeah. There you have an atom. So, it took a while to get there, but you can imagine that it's not easy to make pictures of that deep structures. Because that's actually what we do. We are quite a very expensive photo camera. And in doing those kind of photo camera shoots, of course, having a good image is not an easy thing, I can assure you. So that gives a little bit of an idea of who we are as a company. A few more small items to tell you, sort of like the smaller you want to see, so if you really want to go to the atomic level, then actually sort of like the machines get bigger. So the biggest ones we have are 4 meters in height. They're pretty amazing to see. I already explained a little bit about where we are, so here you can see where we are with at least the microscopy business across the world. We serve different areas. An important one is life science, so any kind of bio-tissue, human or any other, will be investigated through our microscopes. We have, on the more or less the hard materials, there's both material science, which is metals, plastics, any kind of science there. But also the semiconductors business, which is quite a big business. And we all sort of like trust on the IC market to be sort of well done. So that's where we do all the analysis. And I have a few examples later on, because that was the idea of our talk, to give you a little bit of a sneak peek of the growing importance of data science in our world. And not only our world, but also the world of our customers. Who knows what you see over there? I'll listen in. I hear it, yeah, COVID. This is, well, the left side is the nice artist impression of the COVID virus, with, of course, its spikes that it has. And the right side, it really is an image of one of those spikes. So if you, for instance, had to determine the actual migrations or the variation between, for instance, a Delta variant and the Omicron variant, you have to go to the spike level to really investigate on the deepest level of where sort of like things have changed and how that will work out for future vaccines, because that is, of course, something that you really have to look in detail to. And actually it ties in a little bit into the talk of our previous speaker, because I think that if you look at, for instance, diversity and inclusion in the health market and in the medication market, there is a lot of difficulty that a lot of the tests have been done indeed on white males, you could say. And what we are doing, for instance, with our machines is we are helping the pharma industry to even go to personalized drug development. And then there will be sort of like a different medicine for every person, and it will always be a good fit. So yeah, we really care for that cause, and it's super nice to be part of that in our company. So that's a little bit of an introduction. Time to go to a few examples. So I will do the examples that have to do with our images and the way the microscope more or less gets to its outcomes. And Duygu will tell a lot about our super exciting project that we have to make sure that we actually use system data in a very smart way with the data science. So, a few examples. First one, this is an oldie, but it's still a nice one. What you see, probably difficult to figure it out. This is the insides of a microscope. And if you look in the inside of the microscope, then the way how it works is you have to put samples in there to see something about that sample. And you can do that through various holders that you put in. But it really makes a difference whether you put in the one or the other holder, what kind of procedures that we will start. So we have automated that simply by looking at the different sort of like things that can be on stage. There's even one in the middle, the upper one in the middle, that is an empty stage. So it's also important to know that nothing is on it. So that's how we did a little bit of automation for our customers with the first steps of machine learning, actually, in this case. Well, this you can imagine. I already explained in the beginning that it is super hard to really get very sharp and clear images. So anything that we can do with denoising and image improvement is super important, of course, for us. And we're doing that as post-processing, but also as a solution in the microscope itself to see it while you are making a series of images. So just a few nice examples there. Okay. Sometimes we can do things ourselves, and sometimes our customers are also scientists, and they also are data scientists in a lot of ways. So what we do with this example is that it's not only sort of like you can see some segmentation of some life science structures to the right side, but also to the left side. You can really model sort of like a kind of sort of like prefab things that you put in. So you can make actually a graphical way how you do your data science. And that's super nice, because indeed if you are really trying to invent things, or if you want to find your way into science and detect things that have never been seen before, it's really difficult to do so. Actually, one of our microscopes a couple of years, we received the Nobel Prize for really fundamental investigations to more or less the basis of life, our proteins. So that's the thing we also do, just help our customers with that. Then, last examples from my side is about the semiconductors industry. So in the semiconductors industry, what we actually do to investigate the ICs is we destroy them. And the destruction is necessary because you have to more or less see more or less through the layers of your chip what is happening inside. And usually you do that either with faulty ICs or you do it in the ramp-up phase. So it can be anything between the two. To show a little bit how it works, I'll show you how that works how we actually destroy a chip. That's where we go.
iFast guides the user through a site identification and protective deposition process. The recipe then configures the FIB and places bulk milling patterns optimized for throughput. The sidewall faces are then cleaned to produce a sample of uniform thickness. Then the bottom and sides are cut free from the bulk substrate. iFast then guides the user through the process of using an in-situ manipulator to lift the sample free from the substrate.
Okay. The video is much longer because there's a lot of process steps behind it. But one of the things that you can see here is they have to take out a lamella out of an IC to actually investigate it. And the moment where you do your lamella, you have to be at the right spot, and there's a whole surface, of course, that you have to choose from. So how do they actually do that? And for that we have a solution that actually takes the images as you are milling your IC, and the moment where you are milling, we do some clever deep learning. I'm not allowed to speak to the details of how we do it, unfortunately, today. But the idea behind it is that if you know sort of like certain things, and it has to do with the segmented marks, then you can actually do an automated process of stopping at the right moment so that the operators are not doing all the sort of like milling away another piece, looking at it like, nah, we're not right there yet. So that's a super nice way to make automation work for our customers. So what you see is that these kind of solutions, and of course we do that, by the way, we do that for a whole wafer, so you can do it for all the cells. You destroy the whole wafer, it's a lot of money, but they can use it, they can take it in the semiconductors industry to actually do sort of like all those repeatable setting of milling away the materials. So this is a little bit of an overview of how it works. So I think in the past our company, and at least a part of our company, the Electron Microscopy, was all about the hardware. Then we moved over to the software, and now we are really into data science. So things are really changing. It means that we can do special things for it, but also our customers are benefiting a lot from the data science that we have. So that is where I will hand over to Duygu.
Yeah. Thanks a lot, Yolanda.
There you go. Yeah. Oh. We're not ready.
So, the way we used to do service was called break and fix. So, an error occurs in one of our microscopes, and our customer calls service organization. Then a field service engineer goes to customer side, tries to diagnose problem and fix it. And as you can imagine, this is not the most efficient way. And what if somebody could foresee the problems even before they occur, or a service professional fix the problem remotely by reaching your microscope, or you can see the health information of your microscope timely and in an accurate fashion. And this is how we do service right now, proactive service using the power of data. So what are the steps? We create a massive amount of data in our microscopes since they are really complex systems. We transfer this data to a secure data archive, and then we run our algorithms and models on this data. We create valuable insights and information. And there are two steps to follow for these insights and information. One goes to our service organization. So our technical experts monitor the alerts, and if it is necessary, they notify service engineers and application engineers, and they try to remotely connect our microscopes, fix the problem. If they cannot, then after that, field service engineer goes to customer side. So this is a much better way. And another path for this information and insights is our customers. We provide actionable insights to our customers using our Connected Care portal. And I want to dive a bit more deeper into the Connected Care portal. So let's watch this nice video.
When you access our Connected Care service through the Thermo Scientific Accelerate and Advance portfolios, your instrument is plugged into our secure network. This system data is aggregated and displayed for convenient analysis via the Connected Care portal. The portal is a web-based application that gives you valuable information about your system. Using the portal, you can address system issues proactively before they impact your sample, highlight opportunities for optimization, and drive efficiency in your facility. The center of the Connected Care portal is the dashboard, where you can view information about the utilization and productivity of your instrument. The dashboard also features real-time system status and key indicators of instrument health. Via the Compare menu, you can view the status of multiple systems at once, even in different facilities. While using the portal, it's also easy to access reports, service history, and warranty information. And it's secure, offering peace of mind that your data is protected. The Connected Care portal is the easiest way to monitor your instrument, and is just one of many features within the Connected Care service. This is the future of service. This is Connected Care.
Yeah, nice, isn't it? So, yeah, I want to go a little bit into more detail. So yeah, this is one of the pages of the Connected Care portal. It's called System State page. And through this page, a customer can observe the status of the system and main modules. So it gives the health information. And you can also observe main parameters and your service calls and status of the service calls. And another page, this is my favorite one, consumable monitoring. So what's the consumable? It's part of the system that wears out, and you need to change them periodically. And if a consumable finishes its lifetime during a process of the customer, it can be really costly. It can be even more costly than the consumable itself. So therefore, we proactively maintain our consumables and alert our customers in a timely fashion so that they can take the action to replace it. And lastly, this is our system comparison page, and some of our customers has multiple systems installed. Looking at this page, they can compare the productivity and utilization or other parameters of their systems and balance their work fleet. Yeah, so with the slides, we're coming at the end of our presentation. And as you can see, we're applying data science in various fields using different kinds of data, and we're really excited about that. So therefore, we will continue innovating and inventing the way we use data science. So thank you.